Have you ever tried to reply a message on your phone when you are driving? Have you ever tried to search something on your phone when you are walking on the street? Reading requires more efforts, especially visual efforts, and at least one hand remains on the steering wheel. Using the smartphone at the same time will cause traffic accident. Walking also requires many visual efforts and connecting efforts on routing. Using a smartphone meanwhile is distracting. You might collide with other pedestrians. Research found that walking deteriorates text legibility, reading comprehension, and cognitive performance. Therefore, the project aims to develop a touch-free one-handed smartphone interaction approach for multitasking. Then we developed two example software with the approach. A shopping list app for people browsing their shopping list when they are in the grocery stores. The other one is read and answer app for a scenario like reading a message, then select a quick reply on the phone when walking on the street. First, we introduce some gestures. Surface gestures are the most common method of current one-hand interaction. They refer to the touching on the screen, such as direct touch. In surface gestures, the thumb is usually the only finger to interact with the screen. However, it has lower motion ability and often occludes the target. Motion gestures refer to the gestures that interact with the physical device, such as tilting the phone or flipping the phone. Researchers found that the user prefer using X-axis and Y-axis motion gestures other than surface gestures. Back of device gesture refers to touch on the back of the device. In BOD approach, index finger is the leading role, which provides higher motion ability and wider screen access, but it has higher connected demands and slower task completing time. There is also a term called delimiter gesture. The delimiter gestures are used to detect the beginning and end of the gesture. Through literature review, we concluded that the main limitations of surface gestures are the visual demands and low motor skills, while motion gestures are more efficient with fewer visual demands. Then, according to the findings, we selected X-axis and Y-axis motion gestures, tilt and flip, as the simulating gesture for scrolling contents and turning pages in the developed smartphone applications, and we use double tap as the delimiter gesture. We ran a pilot study on the developer to measure the performance of the Read and Answer app. Overall, tilt and flip presented as intuitive and simple interactions to stimulate scrolling or turning pages. Flip and tap also can be used to present binary selecting. Select one out of two options. The gesture enhanced the accessibility when interacting with a single hand. The pilot study also confirmed a delimiter improved the accuracy of detecting gestures and provided a higher degree of freedom to users on one-handed interaction. In summary, the project designed a gesture set to improve the one-handed smartphone interaction in a multitasking context. With the benefits of motion gestures described above, the design gesture set is primarily focusing on motion gestures. Tilting and flipping showed are efficient as the scrolling or flicking simulators. The results of pilot study indicated the chosen gestures enhanced the accessibility on one-handed interaction. The study also verified that a delimiter facilitates motion gesture detection.